Morning, everyone. Today, actually, going to talk about, as mentioned, like Game Boy coming to the web, but we're actually going to do more than bring to the web. I plan to also do a demo running the desktop and using Rust and WebAssembly. Before, I would like to introduce very quickly myself. My name is Raphael, and these are the social media that you can find me. If you have any trouble saying my name, it's actually from the cartoon. But I think like it's a very common name in Italy, so things should be covered up. And I think that that's the max they're gonna introduce myself. I don't believe that you guys came here to hear about my story. I maintain a project called Rio Terminal, which is I think there's the sticker is one of these size. I don't remember. I is a very fresh terminal. I think like has been more than a year of work and 6 months of open release, and people are using soon will be coming for the web as well. And I do have plans to make it run the Nintendo Switch at some moment. Is powered by Rust and Web GPU, so translates to Metal, Vulkan, and anyway, if you like to have a sticker, just come talk to me later. I'll be very keen to give. And I wrote a book about Rust and WebAssembly. I used to try my best to contribute for WebAssembly and mostly in the binary toolkit. And if you don't speak Portuguese, sorry for the additional propaganda. So first, before we start, I would like to actually talk about some disclaimers. Like the first disclaimer is like nothing of this talk is written in stone. I'm not a big fan of like be discussing technologies as I see it more as a tool. I think with more time, you just see beauties of every language. So everything that you see in this talk, you should be able to replicate with Rust, Go, JavaScript, Java, or any programming language they want to. And other cases, I also talk about some opinions, but it's I don't think that these things are written in stone. Disclaimer number two, this talk does not endorse or promote any type of piracy activity. Just write emulator is super fine. Like is the act of build the install emulator is not illegal. And disclaimer number three, there's a lot of concepts that a Game Boy emulator needs to properly work with. And we're not gonna address or I'll briefly talk about it, like for example, clock speed. I will not talk about all the interrupters. And there's a lot of things that actually I will not cover up, for example, yeah, but I will leave some links in the end of the talk if you want to deep your knowledge through about Game Boy. And cool, let's start our Game Boy journey. So before, in the past, a long time ago, someone told me that if you want to learn how a specific computer works, there is no better way to learn than actually emulating that computer. And I personally always wanted to learn how a Game Boy works, which leads to I need to understand how an emulator does work. And emulators in general, they follow one. I think you can follow the common explanation for that. And it's basically a hardware or software that enables one computer system, call it the host, to behave like another computer system, call it the guest. And you can see emulation basically everywhere. Like you see, this case, for example, is the Windows XP running our Archimedes emulator to the ZX Spectrum emulator. You can see also, for example, in terminals, you have a terminal emulators, the image in the left is VT100. And although, I think terminals, even though they are emulators, they quite extend for example, it's not like most of the terminals they use is not fully today is not fully using what was back in the past. So it's I would consider more extended emulator. And you can see also in games, this was one of my favorite games though when I was a kid. Although the version before the PS1, there was this example, for example, runs the Harvest Moon game in the PS5, and it's a game from the PS1, and it's possible through emulation. And there's a lot of other types of emulator, like you have hardware emulators, network emulators, in-circuit emulators, and server emulators. We have other types as well. But often they follow, is not it's not a rule, but they follow like three types of how can I say three patterns through the code. One of the pattern is like they either would have like a CPU emulator or simulator. They would have a memory module, and they would also have like the I/O emulator and the I/O device emulators. And then often people don't emulate the buses because for like reasons of simplicity or like a performance. So you don't see that happening often. And if you look for Game Boy, actually there's a lot of emulators. I was very surprised because when I was working on the terminal, I felt that the material for write your own Game Boy is way more vast than actually write your own terminal, which kind of made me a bit disappointed because terminals are great, but emulators actually you can find for every language that you want to, and it's pretty vast. But one of the things that I actually found that I thought that was interesting is like majority of the emulators they were targeting either desktop or either web. So what if we can write a Game Boy emulator that can run as a desktop application or even like a browser application or even a terminal application, like kind of this way. This actually exists and works, but no, I'm not going to talk about this one. I'm going to talk about the one that we're going to do together in the talk. There is this project. I created like a mini Game Boy emulator to the conference, and I use it. And for this, I use it like I decided to do with Rust. Like there's multiple tools, programming languages that you can use, but I decided to do with Rust mostly because I really like Rust, but like I like personally the low-level control with the high-level ergonomics. So it's like I can have access to the referencing, like monomorphization, memory layout, and it just feels right to do these things than other languages that I used to work with. So I chose Rust, but you can choose any language that you feel comfortable with. Rust has a benefit that is like does not contain like a runtime, so the WebAssembly like binary files are pretty small. And since we decided, or like a language, let's establish our emulation goal. The emulation goal for today will be pretty much like run a simple game that was created only for this conference talk, and also by the fact that ROMs are not legal. So like considering that the statement assumes that you didn't obtain this legally, but you could of course obtain legally. For this talk, I used the Game Boy Studio Dev. I don't know if you guys know, but like you can create your own games with using that too. And I also found like a few projects that are written in C and one in Rust as well. That you can write your code with Rust to create your game. But I decided to do with this one because it was easier to do. This is the game. I kind of regret putting my face there, but this was running with the analog pocket. I'm not doing any merchandise or like they're not paying me to say this. But after create this game, actually, like when you like export this game, actually you get like this folder with these files, and like you can see like you have like the Intel hexadecimal object. You have like other files for debugging as well, but most of the primarily in this talk we only care about the Game Boy format. For this talk also, I didn't want to write a unified render for multiple platforms, mostly because I wanted to show how a Game Boy works. And so if you have any experience with like HTML5 Canvas or OpenGL, I think that is easier to contextualize what you're doing through the talk. But originally, this talk was going to be written using like just a single code as source for everything. But considering that like this is how it looks like, we have like a file called desktop and a file called was. Actually, I renamed that to web. I forgot to update this slide. But it has a binary and a library, and we're considering a few things. We are considering one, that the library is always going to be a C dynamic library, C dylib, and the target was in 32. We're considering the library will have a completely different code than binary, and both library and binary consume a Game Boy mod. I think this configuration can be a bit chaotic for some cases. For example, if you have like a Rust analyzer, often it considers that comes from, for example, using the Sublime. Like, if it just starts to be a bit chaotic to run this type of things, but you can configure, of course. I just think that it can be better distributed, for example, with Cargo Workspace, or have the same source of code using like target arcs. But this is the way they decided to do, I think, just separate. Originally, this is the very initial point of the Game Boy. We have like a Game Boy that has like return new, width, height, data, frame, key down, and key up, and then has like a button, and the Game Boy basically has like information of the width and the height. Moving that to the WebAssembly, in the WebAssembly part of the thing, it's like I decided to use the WASM bingen. I think everyone here knows, right? Right? Everyone who knows WASM bingen is allows you to create like quick, like how can I say, basically maps your Rust code and makes this communication through the WebAssembly easier. But you can do that by yourself if you want. I often used to do that. I think like it's easier if you don't have like that knowledge about WebAssembly per se. So it's just easy to bootstrap. Basically, you have like not gonna go deep in the code, like you can see later after the talk. But it's like you create like a Game Boy from the ROM. If you have any expertise with JavaScript, you kind of have idea what you're doing now. There's basically we're creating a canvas, and this code is gonna execute in the side of the browser. And inside of the canvas, like I basically I do one frame, and I get the data. I move this for like a U8 clamped array, and I put this image data into the canvas. So this is what should look like up and running. You can see like the numbers like increasing, but it's just a black screen. And if you see that in the OpenGL, in the OpenGL is completely different. Also, is like you have the vertex, you have the fragment, and I cut it a lot of like the GL context, but I left in the code later if you want to take a look. But basically, the idea is also simple and similar as well to the Canvas solution. There's like you receive a Game Boy, you set like the texture image 2D, and you have like the width, the height, and the data as a pointer, and basically you load the room data from the file, and once you read the file, you send to the Game Boy, and then in this case, actually, I'm using Gluten, but you can use any window, like you can use Winit if you want, or like there's a lot of other options to work with Windows in the Rust. But like this one is the Gluten, and then every time the redraw is requested, like do a frame, draw the Game Boy with the function that we saw, swap the buffers, and do again. And on top of that, we have like the configuration of the window, which is basically the width and the height of the Game Boy. And if you run this code, it's going to look pretty much like this, beautiful. It's like does not tell much, like it's pretty much what happens. But this is just a part. Like this is the part that actually is not like the knowledge that we care to actually port the Game Boy. This is just one part. Like I think that this part that didn't want to stress enough in the talk is just like these are tools, but they actually source the knowledge that you need is from the Game Boy. Whatever you decide to do, which language you decide to do, how you decide to do, needs to come from the Game Boy itself. And this case, for example, you have like a scan of the main board, and often you would see like this DMG, and I think it's funny because like a lot of people say that, and they are considered that everyone knows that, but basically it stands for dot matrix game. If you had the Game Boy, you would have like saw this when, yeah, you own it at some moment of your life. But a lot of people they didn't know. So I see like often these questions coming up like in the community. But the technical data of the Game Boy is like you have like the CPU 8-bit based, You have like this clock speed, the work run, the video run, the screen size, like all this information can get like anywhere that you want, like in the internet. There is also one thing that I would like to highlight. There's like Game Boys, they came in different mainboard models. For example, you would have like the MG CPU 03, also you would have like the 06. The difference are very subtle for programmers. I don't think like if you're emulating Game Boy, I mean, in some level, yeah, I would just say like for emulators, I don't think they actually care about this difference. But if you're actually working with the hardware emulation as well, I would say that it pretty much matters at some level. And the simplifier hardware overview is basically input, process, output. Like nothing like, how can I say, no, I don't think that there is so many magical things like regarding that. The input is basically everything that you see in the Game Boy, like for example, regarding the, well, pretty much input, like the buttons. And you would also have like the volume, the external connector, the jack to plug in external power, the contracts control, the power on and power off. And you also would have like an interface for serial communication. I think people use it that mostly. I don't know if you have someone on the Game Boy, like they had back in time the Game Boy printer. So it's like you just use it that also for print. And the cartridge slot for game cartridges. So basically, in the end of the day, you have this up, left, right, down, select, start, A, B, which is, well, a button that like you can have different, like you can write this in any language they want to. If you move that to the desktop, like in this case with the Winit, basically you're just mapping that to the virtual key code and just like, okay, if it's this, like I want to do a key up, key down. If it's that, I want to do a key up. And in the web, I think I did a bit more. Is more like written, like how can I say, is more manual. Although it has some problems with this implementation. One is like I create like I add that event listening for the key down and key up, and then the trick here actually is like the things that are key up are minus. So like I every time that this happens, like I be doing like okay, like 65 Z. If it's like if it's non-negative value, like then it's a key down. If it's negative value, is a key up. But you can do this how you whatever you want. The when you input this data for the Game Boy, you don't actually tell like, oh, I want like the button A, I want the button B. It does not work that way. What actually the logic over the Game Boy is like with the joypad, and basically it concentrates to know like is like a data with a U8 that basic concentration know is values from 256 and basic concentration know like the state of the keys. So you have the first row, the second row is a matrix of 2x4 and basically tells like which buttons are up, which buttons are down, basically on the row. And you can see later in the code, there's no magic in that, as long as you understand how the joypad works. Moving to the processing. The processing is like, I think is one of the most exciting parts of the Game Boy because you have like so many different components through the to the main board. And one of the components that like in the genre, I feel that most of the tutorials start is the memory map. So you have like this VRAM, the RAM, the crystal and the amp. I just map it just for us to see, but we're not gonna enter in details. But in the memory map, you have like the boot room, the game room, again the game room, the tire RAM, the background map, the cartridge RAM, like. And if you want to see these in the more simplified view, you also can like I think that this one gets easier to see like different parts of the memory are separated for different purposes and they are accessed by the Game Boy like the by different components of the Game Boy to actually retrieve some information that they use. For example, in the work RAM is basically general purpose usage. Is funny that it's like 4 times larger than the Nintendo Entertainment System, and because it's just 2 KB. Well, back in time that was a lot, but The display RAN, also like also called video RAN, contains most of the data to render graphics and basically contains tile data and tile maps. If you had to represent this, people often they write as MMU, which is like memory managed unit. The ZRAN is actually the high RAN. And you have like the input, the GPU, and the memory bank controller, which we're going to talk soon. And when you create these things, like when you create the memory, you start this memory, you actually need to start with from initial values. Like cannot just start from scratch. So in your case, like we need to also map this memory. So everything that we saw like is mapped this way. I saw many cases actually where people do minimal mapping in the emulators. I don't know if it was on purpose or if it had like some goal. We didn't have like a good explanation through that. But most of the times, the solid emulators that I saw, they map literally everything, and the MMU is very simple. Like it reads byte, write bytes. Like here, example with like the read byte, it gets the address, like read the address. Take the address and then do the operation that it's supposed to do based on the address. So, for example, in the first address would read actually the room from the read the room. The other address would actually read the byte from the GPU, and the first one is doing this read ROM from the ROM. I think the process that way it tends to do this mistake. But the first one is in the memory bank controller, which is like every Game Boy have. Most of the times, like since the Game Boy, since the Game Boy 6 has like a limited space, there is how can I say, this extra space from the memory bank controller in the cartridge. So it's not in the Game Boy itself. And in your case, we do actually need, because our game is more than 32 kilobyte. So we do need to write some like small implementation. We didn't like in the code is not everything implemented for like MBC one, but the memory bank controller that we need is the one, and is in this code is just a variant from the memory bank. The first memory bank controller, you have like different kinds, and depending of the kind, actually you would have like a timer, a serial, like you have like these different functionalities that would come in like inside of the memory bank controller. But in your case, it's a very simple like game. We only care about very specific data from the ROM, and then basically we are reading and writing, but it's like mostly reading. The next component is the DMG CPU. The name of for the entire system on chip is actually Sharp LR35902, while the microprocessor is called Sharp SM8083. And the Game Boy CPU is actually a hybrid between the Intel 88 and the Zilog Z80. The Z80 was designed to be binary compatible with the already existing like Intel 8080. So the instruction set that was found in the Intel 8080 is also implemented in the Z80. And they introduced a lot of functionalities in the Z80, but not everything actually was gone through the Game Boy CPU. One of the things that actually went was the extra like instruction set that runs like 256. And this was important for the Game Boy, gonna show you soon. But I actually had many slides about this difference, but like since the time is short, I decided to just like add this information. If you want to learn more about these both microprocessors, is very good. Like is the manual, the details, a lot of things. I actually skipped like 9 slides regarding this, and I think that like is great. If you learn those, you can pretty much like implement like you have a really good understanding of how the Game Boy works. And in the case of the Game Boy, and is like the processor is connected to most of the elements on the board. So it also relies on the program counter that reads the state of the I/O, which is kind of different from others like architecture for microprocessors. There's like you don't have like this special instruction to access like I/O input. In the case of the Game Boy, what actually happens is like the bytes from the memory are like read like according to the program counter and register, and then you have like the other registers. There are A, B, C, D, E, F, H, L, and other 16-bit registers, the program counter and the stack pointer. And if you look that in the Rust perspective, it's pretty much look like this. Like it's not like it's like that is it. And you need to actually implement these things through Rust. But if you have an idea of how registers work, is actually is not that complicated. And in the bottom, like I left this link, you can see like there's way more information if you want, but you need to implement most of the instruction sets for a game. I think it was 186 instruction sets that I had to implement. So it like looks a bit like this, and remember that I talked that had one extra that was like 256, which is this prefix callback, which is in the pink one. Is it also has extra instruction sets, so you also need to implement these things, and it does not look that like first time when I gave this talk, like people were like, oh my god, like I'm gonna do this, and after they saw, they're like, okay, it's not that complex. Basically, the idea is like the first one is like no operation. You don't really need to do anything, but in this case, actually, I'm returning one because I'm counting as a tick for the clock. But since we're ignoring clock speed and all these things, like you don't actually need to implement these things. And you have like in the other one, you have the read word that comes from the memory, and you'd like set the register's value based on like the instruction. And how it works in the overview is basically like I read the byte, I do the cycle, and after I do the cycle, I do again, and I do again, and then like it keep happening. This is not the most faithful example because like, I mean, this is basically ignoring all the interrupts, but pretty much work that way. And talk about interrupts. Interrupts are quite important in the Game Boy, but because of the time, like I'm gonna briefly talk about it. It's basically a 8-bit value consisting of flags, and they can actually interrupt, of course, the current program flow. So what actually happens is like we saw that CPU executes the instruction of the program count, like based on the program counter, and however, whatever the interrupt is put in action, the program counter is moved to the stack and run the opticode based on that interrupt. So the Game Boy has interrupts for like the GPU, the buttons, the joypad, and pretty much looks like that. I'm gonna run the instruction B, but there's an interrupt instruction, then I stop that, move to the program counter to the stack, and then I only come back there after the interrupt is done. Moving forward, output. The output is, well, if you had a Game Boy, you're not, it is a familiar face. This is the Super Mario Land, and this like the Game Boy has an internal speaker with a mono sound output and like headphone jack with the support for the stereo sound. And the audio system actually is processed by the audio processing unity, and is basically based on the pulse waves. I actually have the sound here, but I don't know if it's gonna. Okay. And I think everyone recognized that. Like the display is 160, 144 pixel display, and is a LCD, which is people like they're like, oh, why? For example, if you have a Game Boy Pocket Lite, you see the difference. Sometimes you see the Game Boy has like this, looks the colors are different, but actually is because the non backlit LCD has like this display background that is greenish. So you have like this green scale. So if, for instance, if you get the old Game Boy and then you put like the backlit LCD LCD screen would look like this. So it's basically like how the LCD is set it up. Uh, the everything that actually is rendered to the Game Boy comes from the picture processing unity, and is a very like how can I say, is a very complex, like not that complex, but it's like there's a lot of elements through the PPU that will actually skip, but it's basically used like for tile rendering, and it divides into between background and sprites. So you have like, for example, in your game, you have like this is stored in the VRAM, the video RAM, and this region is called a tile set. And in order to build the picture, the tiles are referenced in another type of table called tile map. So you can see like it basically like goes there, picks up the data of the tile, and then plots to this screen. And the PPU is very, how can I say, has a lot of things. Like it's way more than that. Like it has control of the display. It has like, for example, it renders the background. It also coordinates how the sprites are rendered, and you have like different modes based on the interrupt. So you also have like the scroll. Have you guys played tennis in the Game Boy when you're like, no? But like in the tennis screen, it's funny because like if you go for emulator and you move to the side, the scroll goes together. Actually, I have example of that. I forgot. Oh, the sound as well. But you see, for example, the background map. It is there, exists, but like what actually is changing is the scroll of the screen, and the tile data is being actioned. So in this case, you have the scroll basically changing all the time based on the input of the user. And yes, I think like not only that, like the sprite has like has different information, and this information is also saved in a different, saved and dealt with different ways. There is like this object attribute memory, which contains like the position, the tile number, the priority, the flip X, the flip UI, the palette, and this changes how the sprite is going to be rendered. And this also has the PPU. Often you would see like emulators call it as GPU. Would have has different modes. These modes are very important to connect with the interrupt, because it could be that the PPU is actually reading data from the memory, and before to proceed to actually render stuff, needs to render things in priority. So the background needs to be rendering the different time actually the sprite, because of course the interaction that the user is going to have with that is going to change how the whole flow of like how the PPU is going to actually proceed with the rendering. The PPU also has as the memory. It does read byte. In this case, it's reading from the VRAM. The other one is reading from the object attribute, and that we just saw. So it's like it consumes the memory to see how should be rendered, like how the things should be plotted to the screen. And I think the part that everyone was looking forward to, the demo, cargo run, is demo. I think like I did this talk internally in my company, and then was fun because people didn't work with Rust, and then they're like, so what is cargo run? Like, but it's pretty much it's gonna run for you the binary. The desktop like example is basically creates this screen and then proceeds. And then you have like yeah, below there RustLab, compact, and plays a dumb music. But it is in the web, for example. I installed this project called Cargo Server that I maintain. So if you find any bug, like please let me know. and the Bingen like CLI. So I'm building from the same source code coming from the library, and I opening a server. But you can use Python or like whatever you want. Like there's a lot of built-in servers in different languages, and it actually I compiled to the 1032 and 010 target web no TypeScript, and this is what should look like. And there is no magic behind it. Actually, I just plot in date of an image there, and like dealing this with different frames. I think is a fair, easy like example to do without the bindgen, because you don't like the type of data that actually we're dealing with are not that complex of data. You're dealing with like array of U8 that you can actually, of course, you're gonna size it, and it needs to be sized. And you dealing with the input there is also U8. So it's like is quite I think is a fair, simple example that you don't really you can do that by yourself, like without have like these modern tools, I think. But the Game Boy is like so much more than this, so much more than actually was showed here today. And I promise I left some links here. There's like links that you could look, and other links as you could look as well. And I think that's it. Thank you very much.
Sa. Okay. Okay, thank you very much. Now it's time for you, if you have some questions.
The stickers, if you guys want later.
Huh? Okay. So, does anybody have a question, comment? Yes. Oh, sorry.
Yeah, thanks for the talk. My question was, did you encounter any problems like managing kind of the clock, or when it came to, should I ask again for the audio?
I didn't hear.
Okay, sorry, yeah. My question was, did you encounter any problems managing the clock or writing the frames, like animation frames?
Not really. I think like the documentation is pretty straightforward. Like if you see the other, like I left in the first, I think this one. You like with Rust, you can see this R boy. I think like the code is pretty straightforward. You see and you have a good understanding of like the interrupts and like the clocks as well. It's not that like how can I say is not that like complicated. But I think I had to condense the talk in 40 minutes, so I didn't want to jump on that.
Yeah.
Yeah.
Okay, sure.
But should be fair, simple. Like you just map the ticks, and I also need to deal with the interrupt and deal with the right clock, like every time they run the cycle.
Okay, cool. Thanks.
Sorry.
Quick question. Thank you for the talk. Super interesting. Did you try running like other ROMs you legally acquired?
I already know answer this question. but yes, there is a site that is, I think is itch.io, the name, and they have like this great collection of Game Boy games. And in the other Game Boy emulator that I wrote, there's basically full made, not just a mini version. It has like I could play the whole game with sound and stuff like that. So it is this is more like a condensed version, but it's like the big version works with the ROM as well.
Do you have a Game Boy with you right now?
Man, I actually was coming with it, but I decided to come with my Steam Deck. Because I came by train. It was a long travel from Sweden, so I did like 3 nights of train.
Sorry.
Amazing talk. in the instruction table that you showed in the beginning, there were two numbers. One was the number of cycles for the instruction, and the other one was unknown to me. Can you elaborate on that? It was like a number 12 or something, and I was confused by that.
Yeah, I think like this one I left the link in the bottom. They have like a good legend of like those numbers, but it's like if you go for other instruction sets map in the web, they consider they're implementing that way. So I think that case you talk about the tick, and the other one is basically uh, related to the type of the instruction like that you're doing, because could be ALU, like you have like these CPU terms, but I honestly don't remember the legends of that. Like if I be honest, because everyone maps in the different way to follow the same pattern. If you know what I mean, like you would see like different maps that would have like contain the clock tick, but the other ones would completely ignore that. You found this later, like so is. But in the bottom of the I think I left actually there's a link. I'll leave the slides. Oh, in the top actually, there's like the explanation as well. So it should like be like actually other is a good question. When I started to write the CPU, actually based it on a good article from hope I left this in the. I hope I left this in the. Yes, this article. I'll try to point this. This one here is quite good for like the CPU implementation. Like implements in JavaScript, but I think that has like a good understanding of like the CPU in the as a whole. So I don't know if you answered, but
Yeah, perfectly. Thank you.
First, thank you for the talk. It was really interesting. My question is about the Game Boy Color. I know the CPU is almost the same, but would you have to change something in order to make a Game Boy Color game work?
yeah, excellent question. The difference are very small. Like it has like very small changes in the PPU. So the PPU considers they have more color. That also has changes in the memory map, because like some memory address would have contain like a small information that you would treat different if you're running inside of a Game Boy Color. But if you have like the Game Boy running for the Classic, I think that no, I don't think actually. I started with the Classic, then I ported to the Color in my other emulator. Is fairly small like changes. I think changes a lot if you go for example, from the Super Game Boy Advanced Game Boy. This is like completely. Yeah.
Thank you so much.
No, thank you, sir.
Can I just say a fun fact though? With the one of the things that I think that is super interesting with the Game Boy is that you see the memory map, and there is this area that is like unusable, and actually like the third one, if I'm not mistaken, but it's like it's basically Nintendo does not allows you to use that, and if you use like is like most of the Game Boys, I saw even in a talk like that they are required to display the Nintendo logo, and that they do like a test to the image, otherwise I think there's such a interesting thing. There's so much about Game Boy that you can learn, that like these facts, it's hard to condense everything in the talk. Yeah.
Okay, so thank you very much, Raphael Amorim.